Math 152 students. In this video, we're going to look at some tips for levels of measurement. The first tip that I have for you is to back up a step and think about qualitative and quantitative. If you can identify whether your variable is qualitative or quantitative, you can narrow your choices from 4 to 2. So qualitative variables have to be nominal or ordinal, whereas quantitative have the option to be interval or ratio. Let's think about a keyword for each of these, and I'll illustrate what I mean. For nominal, think about the term name. For ordinal, think about order. Interval, you want to think about subtraction, and ratio, you're thinking about division. If you don't have a number, you can't divide or subtract. What that means is, if you're dealing with color, or like hair color, eye color, you can't subtract or divide those. So 3 and 4 don't even make sense. You're going to be stuck in nominal or ordinal. Then, if you know it's a number that you can do math with, you have to decide if the subtraction or the division makes sense. So you're going to be interval or ratio for quantitative. So let's look at an example first, dealing with nominal or ordinal. I'm going to give us an example and we're going to decide which of the two it goes in. Let's say we are looking at the movie rating at the movie theater. So what do I mean by movie rating? Like R or G, PG-13, PG. Now I said those and you must say, she's saying them out of order. When I give you a list of ratings, you know the natural ordering. So not only does G label a movie as appropriate for certain ages, but when you compare it to PG, you know PG is for a slightly more mature audience, and R is much less appropriate than PG for certain audiences. So what that tells us is the movie ratings are ordinal. So think about ordinal. You order, so it not only names, but it orders. Think about these as progressive. But that's the best that we can do with it. You can't really subtract G and PG. That doesn't make sense. You can't divide. So let's think about something that's not a number or not a quantitative variable, but that we can't order. So let's think about hair color. You might have blonde, brown, red, gray, white, different hair colors. And you don't have this natural ranking in the same way that you do with movie ratings. Those values of brown hair simply labels and puts them in a classification. For interval and ratio, let's start with a quantitative variable. Let's say we have the quantitative variable age. So your age, meaning you might be 30 years old, someone might be 20 years old, or 10 years old. You know you have to be either interval or ratio. And it's progressive in the same way. If you're interval, you can name and order, but also subtract. If you're ratio, you name, order, subtract, but also can do division. So think about the level of measurement telling you the farthest or the deepest level that you can go. So with age, we want to ask ourselves if we can subtract. So 30 minus 20, a 30-year-old compared to a 20-year-old, has an age difference of 10. The older person is 10 years older than the younger. Or 30 minus 15 is 15. There's a 15-year age gap. That makes sense. But before we stop there, we have to ask ourselves, can we divide? So let's say we are comparing that 30-year-old and that 15-year-old. Well, if you do 30 divided by 15, that's 2. The 30-year-old is twice as old, or has lived twice as long as the 15-year-old. If you divided the reverse scenario, you would get 1/2. Sometimes it gets a little tricky. If you were to pick numbers like 30 and 25, those numbers don't divide as well. You would have to do a little bit more thinking. So when you're considering the ratio level, try to think about values that divide well. If you can't even think of values that divide well, that could be a problem. right? If you can't think of a scenario where you can make sense of a twice as old or twice as something, that could be an indication that you might need to think about interval. So let's put this one age. So for my next example, let's think about the year you graduated from high school. So you may have graduated from high school in 2000, or maybe 2010. We already know that year, when I'm listing those values, is a quantitative variable. I can do math with those two year numbers. I can subtract them, for example. So if I subtracted 2010 and 2000, 2010 minus 2000, I get 10. There's a 10-year difference. One person graduated from high school 10 years before the other. But then, think about if you were trying to divide those numbers. If I divided 2010 by 2000, I get a decimal, 1 point, and then some yucky stuff, right? Can we make a good sentence out of that? Not really. And part of the problem is the way these numbers are, right? They might be 1990, 1980, 2000, 2010, but the divisions don't have a lot of value or don't have a lot of meaning. That means we're going to be stuck in the interval. The subtractions make sense, but we can't do the divisions. We can't look at the ratios. The high school graduation year. The concept of birth year is similar. So birth year, if you think about the year you were born, subtraction makes sense but not division. But if I tweak it a little bit to age, then age becomes ratio because of those divisions. You could also think of, for ratio, birth weight of a baby. You got a 10-pound baby compared to a 5-pound baby. There's a 5-year difference, but if you divide 10 divided by 5 gives you 2. One baby is twice as large as the other. So hopefully that clarifies and helps us make sense of those a little better.